Swayam Prabha. Digital India. Educated India.
Welcome to Module E, Lecture 10. In this lecture, we shall continue our discussion about operational analysis of signalized intersection. In Lecture 9, I mentioned to you about the various steps that are required to be followed to carry out a complete operational analysis, and we discussed in details about step 1, 2 and 3. So, we shall continue our discussion today and we shall start with step 4. Now, in step 4, we actually do the estimation of saturation flow rate. Now, of course, in step 3 we have seen that we have used a saturation flow value. So, actually step 3 and step 4 will work in an iterative manner. So, every time we need to carry out the calculation in step 3, we have to actually come back to step 4, get the saturation flow values and then go back to step 3 again to complete the calculation. So, you have seen that I said that just assume that the saturation flow is given like this. So, where from it is coming? It is coming actually from step 4. So, there is always something called base saturation flow rate. That means, it is almost we can consider some kind of idealized situation when there is no other factor present which might influence the saturation flow value. Always might influence means in this case always bring down the value. So, the base saturation flow is the highest possible value under idealized condition, and then we need to do a number of adjustments using appropriate factor to get the saturation value for a prevailing operating condition. What are the adjustments? Number of adjustments. You can see that so many factors are multiplied with the base saturation flow to get the adjusted saturation flow S. What are the factors? Factors are with respect to lane width. If the standard lane width is not available, if it is much higher or lesser, then some adjustment factor. Then adjustment factor with respect to heavy vehicles and grade. Very logically you can get convinced that saturation flow will depend on the percentage of heavy vehicle and also the grade, upgrade, downgrade. Okay. Then adjustment factor due to the existence of parking lane and activity adjacent to lane group. If there is a parking, obviously the parking, the vehicle will go to the parking lot, will come out from the parking lot, and that will create some kind of interference to the traffic stream, and therefore, it will impact the saturation flow adversely. Similarly, the bus blocking effect of local buses that stop with the intersection area. If suppose the bus is standing in the or waiting in the bus stop, then for the time the bus is waiting, that time the lane is not available. So, obviously, the saturation flow rate if we are calculating, that will get impacted. Similarly, the type of area, whether it is within the CBD area or outside the CBD area, because land use and several characteristics are generally likely to be different in CBD area and outside CBD area. Then the lane utilization, that I already discussed in my previous lecture, that if there are multiple lanes, then share of even through traffic, if there is a shared lane and there is a straight dedicated lane for the through movement, the traffic distribution may not be same. Then adjustment factors also for the left turn vehicles present in a lane group, Similarly, for adjustment factors for right turn vehicle, adjustment factor for pedestrians and bicyclists. Suppose the left turning permitted left turn, the pedestrian volumes, it will impact the saturation flow rate. Pedestrian adjustment factor similarly for the right turn group. Then the presence of work zone in the intersection is part of the intersection, the construction activity or the maintenance activity is going on, the whole intersection area as normally available otherwise is not available because of the construction, then that will impact. Adjustment for downstream lane blockage, traffic is getting discharged and the entering may be in one approach. Now, when the traffic is entering in one approach, if all the lanes are not available, suppose one lane is blocked, the lane blockage may happen due to several reasons. There may be some activities like work is happening or maybe some other event is going on, so the lane is blocked. So, wherever the lane will be blocked, that will then impact the saturation flow or the discharge. Adjustment factor also for sustained spillback. If the downstream intersection is red and because of that the vehicle is queued up. Now, how the queue has probably gone much longer and when the vehicle is getting discharged, the drivers also probably can see that there is a queue, they have to join a queue. So, naturally, the way the discharge happens in normal condition will not happen now. So, all these adjustment factors are to be considered to get the saturation flow under a prevailing condition from the base saturation flow. Now, if you look at the highway capacity manual, each of these adjustment factors, how they are calculated, how in a case specific or context specific situation, how we calculate it, it is quite complex, not so easy. And anyhow, when you will do it, you have to refer back to the highway capacity manual 2016 to really know how exactly step by step it is done or what equations you need to use or what table value or tabular value you need to refer. Here I will try to give you some ideas just to help you to understand the overall process. Now, the general equation what I have mentioned earlier, I am calling it a generalized equation or the general equation, because this is something which includes all the factors that are generally possible. But then there are different contexts and in different contexts all the factors may not be really applicable. So, let me try to give you a little bit of understanding about various situations. So, one may be protected, another may be permitted, then left from shared lane or exclusive lane. Like that there are different possibilities, left turn, right turn. So, all cases each of the cases or each case need to be handled separately. So, this is the generalized equation where all factors are present, because that is what is possible, right. But if you take now protected operation, it may be through, it may be left turn, it may be right turn in exclusive lane. Carefully note that we are talking about exclusive lane, okay, not shared lane, and then through, left or right. Now, if you consider the through, then some of the factors mentioned in generalized equation will not be applicable. For example, I said FLT, that is the left turning vehicle, because we are calling about exclusive through lane. So, the left turning correction factor due to left turning vehicle will not be applicable, correction factor for right turning vehicle will not be applicable, correction factor for pedestrian bicycle adjustment for left turn and also for right turn will not be applicable. So, these factors will get omitted, that means they will be taken as default value as 1. Okay. So, I have omitted that. Now, if you consider the left turn, then out of all these factors, if you consider exclusive lane left turn, then obviously the right turn vehicle adjustment will not be required. Similarly, the right turn pedestrians also will not be required, and since it is protected operation as well, I have written exclusive lane, but also protected operation. So, once they are protected operation, also the left turning pedestrians will not be a factor. So, these factors will get omitted from the generalized equation to get the protected operation left turning in exclusive lane. Similarly, right turning, in this case the FRT will be there, right turning vehicle adjustment factor will be there, but the left turning vehicle factors will get omitted, and as usual pedestrians for left turning and right turning both will get omitted, because we are talking about the protected operation, not permitted. Now, protected through operation in a single exclusive lane, single exclusive lane. So, here I have written again then how the saturation flow for the through movement can be calculated. We are talking about single exclusive lane and protected through operation. So, obviously, FLU the lane utilization will not be there, otherwise lane utilization will come. Why the lane utilization is getting dropped? Because we are talking single exclusive lane. So, single lane utilization will not come. Then also along with that FLT, left turning vehicles, right turning vehicles, left turning, and then whatever pedestrians adjustment, bicycle adjustment is required, that will not be applicable, right turning vehicles, and with whatever adjustment is required for the presence of or movement of pedestrian bicycles, those will not be required. So, these are all omitted. Now, protected left turn operation in a shared lane, protected left turn operation in a shared lane. Earlier what I said here, left turn operation in exclusive lane, but here it is shared lane. For the shared lane, you are already familiar to this sorts of equation. I have discussed it, we have used it earlier. Now, if it is a shared lane, then whatever is the through saturation flow, that will get further modified by two other factors. One is what is the proportion of left turning vehicles in the overall shared lane, how much percentage of traffic is actually taking left turn, and also the left turn vehicle equivalency factor, because those vehicles which are taking left turn, they will not have similar effect of the vehicle which are moving through, right. So, this EL equivalency for the left turn and proportion of left turning vehicle. The same exactly for protected right turn operation, these are all protected. So, the pedestrians are not coming into picture so far, right. So, the protected right turn operation exactly the same way. Here again the through movement, what is the through saturation flow, then equivalency for right turn vehicle equivalency and proportion of right turning vehicle in the stream. So, that way we can calculate the saturation flow. Now, coming to permitted left turn operation, once it is permitted, then protected versus permitted, I say protected operation in exclusive lane, and now we are saying permitted left turn in exclusive lane. What is the omission here from the earlier one is this one, pedestrians, right. The pedestrians will come into picture, left turning pedestrians. So, what will get omitted is only the right turning vehicle adjustment factor and the pedestrian bicycle adjustment for the right turn lane, that will not be there, but otherwise the pedestrian adjustment factor for the left turning you can see FLPB, that is there. Now, permitted left turn operation in shared lane, this again the equation is, you are familiar with this equation. Shared lane again permitted left turn, how it will depend? It will depend on protected, it depends on what? For protected left turn operation we said that percentage of left turning vehicle and equivalency, left turn vehicle equivalency. Now, one more additional or one more factor will come, that is what? That is basically FLPB, the pedestrian bicycle adjustment, right. So, pedestrian bicycle adjustment for the left turn, that will come, that will also be a relevant factor here. So, shared and protected and permitted, the only difference is this is protected left turn and this is permitted left turn, the only difference is the pedestrian, right. So, along with PL and EL, proportion of left turning vehicle and equivalency for left turn vehicle, also the adjustment factor for pedestrian bicycles for the left turn. Now, protected permitted left turn operation in exclusive lane. I have also taught you that what is protected permitted operation. So, when the protected period will be there, this is given like this, very similar, very logical, what were omitted you can understand from the generalized equation how we are getting this one. Same way during permitted period, it will be the pedestrian volume will come into picture. So, left turn pedestrian volume will come into picture. So, here the difference is here FRT right turn vehicle adjustment is omitted, right turn adjustment for pedestrian vehicles is omitted, and here it will be only right turn and right turn vehicle and right turn pedestrian bicycle adjustment will be omitted, but permitted the FLPB, the left turn pedestrian vehicle adjustment, that will be coming back, right. So, that makes it very clear. Now, what is remaining is the permitted right turn operation in exclusive lane. Now, here there are two things, the additional consideration between the left turning permitted and right permitted. The basic difference is left turning permitted means only the pedestrian bicycle, the turning vehicle has to yield to the pedestrians and bicycles. So, that is the factor. Right turning case, one more thing is there, the vehicle is coming from the opposite direction, because you are taking right turn and the vehicle is coming, the opposing through movement. Now, when the opposing through movement happens, two possibilities are there. The first is the period begins, flow begins with the start of effective green and ends with the clearance of the opposing queue, because during red the opposing queue, the straight moving, these vehicles were waiting in a queue. So, what happens when the queue is there, one after another vehicle will come. So, that time what will be the opportunity for the right turn or what could be the saturation flow will be very different from this saturation flow during the subsequent period of green. Subsequent period of green means when the flow begins or when the flow is happening after clearance of the opposing vehicle queue. That all the vehicles which are queued up is cleared now in the first period of the effective green, then the later period of effective green there is no queue from the opposing vehicle. So, the discharge will be different. So, when the second period of flow begins, that after clearance of the opposing flow queue, then this saturation flow may be calculated using this equation, which is again logical. The only new term here is the SP. SP is the saturation flow rate of a permitted right turn movement. Now, how you calculate the SP? This equation is given. It is a function of opposing demand flow rate, very logical, very logical. What is the opposing demand flow rate? So, it depends on the opposing demand flow rate. Also, it depends on the critical headway and the follow up headway. So, the calculation is given here, and for the first period when the flow begins with start of effective green period and continue till the clearance of the opposing Q, straight moving opposing through movement Q. So, there will be this SR is going, you can see here, divided by, again two factors are considered. One is ER2, ER2 is equivalent number of through cars for a permitted right turn vehicle when opposed by a queue on a single lane approach. The one is the right turn equivalency is there, but that is under any condition when there is no other thing also, a straight going and a right turn vehicle, the equivalency will be different. But here it is ER2 indicates that equivalency for a permitted right turn. For a permitted right turn, that means the opposing vehicle is considered when opposed by a queue on a single lane approach. The vehicles are in the queue for the through movement, opposing through movement. So, that equivalency factor is different than the normal right turn equivalency, and of course, the pedestrian part will also come. It will again get impacted by the pedestrian. So, FR right turn vehicle and the pedestrian bicycle adjustment. So, that is what it is. Now, with this let us try to get little bit of more understanding how we get the values. Now, for base saturation flow rate, we can normally assume it as 1900 PCU per hour per lane, PCU or passenger car unit or passenger car equivalent whatever you say, PC passenger car per hour per lane. If the metro population is greater than 250,000, otherwise it is 1750. So, as per highway capacity manual 2016. Then this is the lane adjustment factor. It was actually given in feet, but we have also mentioned here in meter, equivalent meter or approximate what is the meter. So, if the lane width is in the range of 3 to 3.9 meter approximately, then it is 1. If it is lesser than then 0.96 and greater is 1.04. Now, this is table I am showing, or in this slide I am showing adjustment factors for three things: heavy vehicles, grade, heavy vehicles and grade together, then bus blockage and parking. So, actually for four things, but then heavy vehicles and grade are combined, because the grade also will impact the heavy vehicles. So, heavy vehicles and grade are combined, then the bus blockage, then the parking. Now, heavy vehicles and grade, obviously the factor depends on the percentage of heavy vehicle and what is the grade. Now, there are two formulas which are given here. One is for the downhill negative grade and one is for the uphill approach the positive grade. So, grade, what is the grade? Positive or negative? If it is negative or downhill, we will use the first equation. If it is positive, we will go for the with that plus value, we will go to the second equation, and then percentage of heavy vehicle and what is the grade. Now, bus blockage, what is bus blockage? Because bus will stop in the normally the curbside lane, right, the outer lane. Now, if whenever bus is stopping, then that time the discharge is getting affected. So, how much time actually the bus is occupying? Now, if that can be estimated, then we know how much time that lane is available for through movement. So, this equation is given, you can say capital N minus 14.4 N B by 3600, the whole thing divided by N. Now, it is almost like if one bus is actually stopping, then the impact is, you can consider like 14.4 seconds. So, if there are N B number of buses in an hour, then N B into 14.4 seconds is actually that lane is not available. So, that out of 3600 seconds in an hour. So, it is n minus this divided by n. So, what will happen if suppose the 14.4 N B becomes actually 3600, just theoretically I am saying, then always there is a bus. That means the whole lane is not available. So, what you have actually, it is not n number of lane, but it is n minus 1, right. That is an extreme situation, but it helps you to understand this equation. In the similar way, the parking, every parking maneuver will have some interference. Sometime in terms of time, a few seconds, 18 seconds you can consider that it is affecting the movement. So, you cannot have the normal movement. So, 18 into Nm number of parking maneuver divided by 3600. So, n minus 0.1 minus this by n. So, approximately you know these are basically logical equations. Now, next is adjustment for area type, left and right turn, work zone, lane blockage and spillback. Now, in this case type of the area, if it is CBD you take 0.9, for all other areas 1. This is the left turn is equivalent number of through cars in a protected left turning vehicle. So, 1 by EL equivalency for the left turn, right turn again 1 by ER similar way, and this I am not going to discuss in details, that if there is work zone, then how to do the adjustment factor, how to calculate it. Similarly, the downstream lane blockage, or if there is sustained spillback, then how to do the correction factors, how to calculate this corresponding factors. So, please refer to HCM for knowing these things, because within the limited time I will not be able to discuss everything. So, if no work zone is present, if no downstream lane blockage is present, if no car spillback occurs, then in each case the corresponding factors will be 1. If nothing is present, that is not a factor, then it is 1. So, always otherwise there will be a value less than 1, and you can refer to this. Now, the next part is adjustment for lane utilization. This you know, you have understood it earlier also, I discussed it, right. But here it is slightly, the equation is slightly different. What is it is doing? The lane utilization adjustment factor, if it is demand flow rate for the lane group Vg, that means total demand for the lane group, divided by demand flow rate for the single lane with the highest volume. Single lane, in that lane group multiple lanes are there. So, the lane which is having the highest demand flow rate multiplied by the number of lanes. So, it is very similar in terms of its calculation, is very similar to the calculation of like peak hour factor. What we do? Hourly flow rate divided by peak 15-minute flow rate. So, peak 15-minute flow rate multiplied by 4. So, similarly here that 4 is not that 4 is for 15-minute to 60-minute conversion, but here similar kind of thing, we are saying the total flow divided by the lane which is taking the maximum flow rate multiplied by number of lanes. So, somewhat like the peak hour factor calculation. So, this table gives you that for exclusive through, for exclusive right turn, for exclusive left turn, then depending on the number of lanes in the lane group. Now, always if it is one lane, then it is factor is always 1, there is no question of utilization or sharing, but more than one, how we take it, right. So, that you can take the value from the table, but conceptually you can calculate it also, or you can otherwise also calculate it based on this equation. Now, going back to our own example problem, which we started in the last week, in the last lecture rather, not last week, in this week itself, the last lecture. So, we continue with that. Here we have to also do, no, this is, I am sorry, this is not that example problem, but now we are talking about pedestrian adjustment factor, I am sorry. So, pedestrian adjustment factor. So, this we discussed about the lane utilization. So, now come to the pedestrian adjustment factor. Now, pedestrian adjustment factor, suppose what is happening here, the left turn, here this vehicles are taking right turn, here also vehicle may take left turn. So, the pedestrian movements are there. Now, the pedestrian along with bicycle also could be there, but we are neglecting the bicycle movement for the discussion at present. So, what we are saying here, pedestrian flow rate during service. What is the service? Service means when actually the pedestrian signal is green. So, what is then that pedestrian flow rate during the pedestrian service time or when the pedestrian signal is green? Very simple. What it is happening? If the VPD is the pedestrian volume, generally at what rate pedestrians are arriving, that is VPD. So, how many pedestrians are arriving during a cycle time C? VPD multiplied by C in some form, taking care of the units. That many pedestrians are there, but they are crossing when? They are crossing during the green time given for pedestrians. So, all those pedestrians are actually crossing during the green time for pedestrians. So, when the pedestrian green is there, what is then the pedestrian flow rate? So, obviously, VPD into C is equal to VPD G when it is green time multiplied by pedestrian green time, effective green time. Okay. So, you can get then VPDG, that means then what is the pedestrian flow rate during the pedestrian service time. Next, it is a stepwise approach again, not so simple. Now, determine the average pedestrian occupancy. Now, that is the pedestrian flow rate during the service time or during the pedestrian green time, and now we want to calculate the occupancy. There are two formulas which are given, one for pedestrian volumes if it is less than 1000 and another case it is more than 1000 and less than 5000 in that range. So, you get the average pedestrian occupancy. Now, once we have got that, we need to calculate relevant conflict zone occupancy. What is the conflict zone occupancy? Is G pedestrian, what is the effective green time for pedestrian, divided by what is the green time, overall green time, effective green time, into this average pedestrian occupancy. Now, obviously, this equation is given considering there is no bicycle interference. As I said that I did not consider bicycle effect when I am explaining the equations. Then determine then unoccupied time. So, what is then unoccupied time? The number of cross street receiving lane, if it is equal to number of turn lane, then it is 1 minus OCCR. OCCR is what? This relevant conflict zone occupancy. Now, understand that if the entire green for this lane group movement, whatever is the green given for a movement and where pedestrian interference is happening, if the pedestrian green is also for the entire period, then OCC PDG, average pedestrian occupancy, and conflict zone occupancy will be same. they will only be different. Suppose the green is for 40 seconds, but the pedestrian green conflicting one, pedestrian green is for 30 seconds. Then in that case, conflict zone occupancy will be different from average pedestrian occupancy, right, because not the full green, entire green which is available for that lane group, they have to face pedestrian interference. But if it is GPD equal to G, then for the entire green they have to face the pedestrian interference. So, depending on that, unoccupied time, that means when there is no pedestrian interference. So, this will only have some positive value if the GPD is lesser than G, then only OCCR will be less than OCC PDG. So, 1 minus this value sense wise, and if it is number of turn lanes, right. So, you can get this. Now, if there are number of cross street receiving lane is greater than number of lanes, then what will happen? Number of turn lanes may be 1, but number of cross street receiving that lane is more than that, or it is 2 and there it is more than that. So, number of cross street receiving the lane is higher. So, traffic will get distributed to more number of lanes when they are entering in the receiving lanes. So, in that case it will not be 1 minus OCCR, but 1 minus 0.6 OCCR, that is what is assumed or suggested by highway capacity manual. There is a logic for everything. Now, how I cannot explain here why the value is 0.6 exactly, but there is a logic for everything, why this consideration is there. Similarly, you can see here left hand adjustment factor, now it will be FLPB will be then this A PVT, similar will be the right hand adjustment factor. Now, coming back to the problem, our own problem, you remember that phase A 1, A 2 and B, the green times are 10 second, 22 second, 16 second, yellow all red times are given, lost time 4 second, crosswalk and 2C is 85 pedestrian per hour in phase 2, right. So, with all this, now we try to do, we are just tabulating the data here. So, demand flow rate, the same data was given in the earlier lecture also when I discussed lecture 9, I used the same example problems, right. So, with all this data, I have now the bay length and everything is available, approach speed, all the data is available. Now, with this, let me try to show you the calculation, how we consider then the eastbound through traffic. This is the eastbound, the eastbound through traffic. How we can calculate the saturation flow? It is considered exclusive lane. So, the general formula is this, but then some of these terms will not get applicable, because there is no interference with the pedestrian, there is no left turning or right turning vehicles here. So, many of these factors will be omitted. So, effectively these factors will be there. Now, FW is 1. What is FW? Because we have lane width 3.4 meter we have said, and as per the table, if you go to slide 9, we have mentioned that if it is 3 to 3.9, then the adjustment factor is 1. So, we take that, we take it as 1, then if HVG 0.922, how we are getting? We are calculating here, this is the formula, and we have 10% heavy vehicle. So, put it as 10% and grade is 0, it is level. So, that is 0. So, you get FHVG as 0.922, and the next correction is FBB, bus stop. Yes, there is a bus stop here, and we have seen that there are 25 buses per hour. So, n minus 14.4 into 25 divided by 3600, n here is 2 number of lanes here. So, 2 minus this, altogether you get 0.950, and since it is a non CBD location. So, area adjustment factor we take as 1. You may refer to slide 11. We have said there non CBD 1 and CBD how much, 0.9 or 95, I also forgot, 0.9, yes, 0.9 for CBD, but here it is outside CBD, non CBD location. You can see here it is in non CBD location. So, that is why the value is taken as 1. So, FLU is 0.952 because it is exclusive through movement and there are 2 number of lanes. You can similarly go back to slide 12 and see how we are calculating. Now, that is for the eastbound. Similarly, we have to do the calculation for the westbound through and left, right, westbound through and left. Now, here the FLP B pedestrian is important, will be a consideration because this is permitted movement, left turning one. So, pedestrian cross minor streets, north south street, it is crossing in phase A2 with a green time of how much? We have calculated as 22 seconds. You know that cycle time is given, the yellow time, the all red time, the lost time all are given. So, you can calculate it, you know this calculation. Now, we are going to step A, B, C and D one after another. So, what is VPDG? Simply apply this equation, 85 pedestrians per hour multiplied by cycle time is 60, green time is 22. So, you get this flow rate during green. What is the, when pedestrian green is there, what is the flow rate? The flow rate is, equivalent flow rate is 231 pedestrians per hour, obviously higher than 85. Why higher? Higher is the overall cycle, how many are coming, what is the rate. Now, all are getting discharged ideally in the pedestrian green time. So, what is the flow rate there? That flow rate is 231. Similarly, you calculate that OCC PEDG in this case, it is 231 divided by 2000 using the simple formula as I have shown here 2 or 3 slides back here. Yes, it is less than 1000 pedestrians. So, this equation is governing. Then we have to calculate OCCR, it is GPED divided by G into OCC PEDG. I have all discussed this one. So, you calculate that OCC PEDG and also the step C, and now you can say 1 minus this is the APBT. So, that comes 0.931, right. So, that is the calculation. So, FLBP is 0.931, that is the one. Now, I take you to this mother table, where I can show then for eastbound, westbound and southbound each approach for each lane group, what are the corresponding adjustment factor values. You can check it, you can do the calculation on your own based on this understanding, and I have shown you how you are actually calculating the saturation flow. Now, while for eastbound I have shown through and right given the value, westbound through I have given the value, southbound also through I have given the value, but for the shared lane I have not given the value, written as x. Why? What is the reason? You know the reason. this value will also depend on proportion of left turn and right turn. So, every iteration when you are doing the calculation in step 3, every iteration your proportion of left turn, right turn as applicable for an approach. Say for southbound shared lane, both left turn and right turn will be there, but for through lane for westbound it will be only the left turn. So, it depends on the PR. So, what I was doing, every time you do the calculation in step 3, you are actually you know what is the PR or PL, corresponding PL, you come back here, put that PR or PL value, then you get a saturation flow rate for the shared lane, protected right turn operation, protected left turn operation, and then you actually go back to step 3 and calculate the flow, link flow, right. So, this is the formula that is to be used. So, I cannot write a value here because it will depend on what is the value of PR. This PR will and PL will control. So, here I have shown the calculation here for our case, southbound through left and through right lane groups. Now, through value is 1728, it is fixed, right, for a given context. Now, first iteration where it started, recall our discussion about in step 3 in the previous lecture, we started with 0% of left turn and 0% of right turn. So, in the initially to start with. So, there with 0 you put the value here as 0. So, you get this value 1728 in both cases. For westbound, southbound we did not do the calculation, but mentioned it that always in the first case we assume that proportion of left turn and right turn in the shared lane is 0. Now, for westbound a similar calculation is done, you get 1577 and you recall, if you recall, there also you use the value 1577. Where it came, where from it came is all through this calculation which is and steps what I have discussed in today's lecture. And because the PL is 0, so S through and SL, because the PL is 0, therefore, the S through and SL left turning is same. So, here I have shown the calculation, brought back those values as well, how we got it. So, you can say every case the through is same, but every iteration how the shared lane left turning, how the saturation flow value is getting calculated depending on the percentage of left turning vehicle, and eventually that is giving you all the final flow VSL, VSL LT, right, that value you are getting. And we stopped after 5th iteration because it converged, there is no change. Recall again, connect it to my previous lecture, lecture 9 and step 3. So, the step 3 table also I have brought it here in a meaningful form, so that the whole thing is available to you, and these are the volumes, these are the corresponding saturation flow, and this is the value of PL and this is the corresponding value of Y. The same calculation I have shown now for the shared lane group through left and for the southbound approach, what are the input data, what are the initial estimates then, and then here also again what is the PL and PR, initially it is 0. So, then all the 3 values are same, but as in subsequent iteration PL and PR values are changing. Similarly, the SSL shared lane left and shared lane right SSR, the values are also changing. Higher the proportion, lower is the value, and accordingly the VSL, VSL LT, VSR, VSR RT, all the values are getting calculated. And finally, this when there is a convergence, there is nothing much is changing, then we are stopping. So, it is actually step 3 and step 4 are working together in an iterative form. You you are in step 3, but then you need the saturation flow, you know what is the percentage of left turn, percentage of right turn. Now, you go back and also for the through of course, you do not have to go back again and again, but first time you have to get the values from step 4 only, and step 4 you have to come back again and again as the percentage is changing. So, the saturation flow for the shared lane, shared left, shared right, for each of the approach and each context, you have to come back and calculate from step 4. Once you have taken the saturation flow value from step 4, you will again go back to step 3 and finish the remaining calculation to get all these volume values, right. So, finally, you get all this, what different direction, different lane group, and what are the lane group flow rate and the saturation flow values, both are summarized in this table, and the red values are something which we could not get directly. So, following all these procedures, we are finally getting it. Now, the last slide probably here is determination of proportion of vehicle arriving during green. This will be required subsequently for our calculation of control delay. So, we know the platoon ratio, let us take arrival time as 3 and platoon ratio as 1. Cycle length is already given 60 seconds based on this example problem and input. So, what we do here, we know the direction, we know the lane group, we know the phase how it is operating, what is the green time, what is the change interval, clearance interval, loss time. So, you can easily get the effective green time. Once you get the effective green time by cycle into the RP, platoon ratio. So, you get the value of P, proportion of vehicle arriving during green time. I think I will stop here. So, what we discussed basically about the step 4, majority of the time we spend how to calculate the saturation flow, first for the exclusive lane in protected mode, and then how interestingly it can be done for the shared lane in protected or permitted mode, and how step 3 and step 4 are working together. Step 3 you are going to step 4, coming back to step 3, finishing the thing, deciding whether you need to go for the next iteration. Then again you are coming to step 3 essentially at certain stage, referring back to again step 4, because your PL and PR, proportion of left turning, right turning vehicles are changing, get the saturation flow value from step 4, going back there, and the whole work is done together. And finally, I have shown you how to determine the arrival platoon, proportion of vehicle arrival during the green time. So, with this I close this lecture. We shall continue again, because we could go up to step 5 and we shall continue. Thank you so much.